So we have an array for which the ith element is the price of a given stock on day I. So we have to design an algorithm to find the maximum profit. You may complete as many transactions as you like, and that is buy one and sell one share of the stock multiple times with the following restrictions. You may not engage in multiple transactions at the same time. That is, you must sell stock before you buy again. After you sell your stock, you cannot buy stock on the next day. That is cooldown of 1 day.
Yes. So this is it is a variation of the sell stock problem. So the simple one will be you can only buy once and sell once, and you have to find the maximum profit that you can make. And the second variation is like you can buy and sell multiple time, but without the last this restriction that you have to cool down by 1. And now we have this third variation that you cannot do multiple transaction, and after you sell your stock, you cannot buy the stock the next day. So we have this thing. And how would you solve it, Saurabh? What would be your approach?
So is the cooldown 1 day fixed?
Yes.
So to make the maximum profit, we first need to buy one item at its minimum cost, and we need to sell it at its maximum cost, right?
Yeah.
So I can wait as long as I want before selling a stock.
Yeah. The cooldown has to be like 1 or more than 1. Like you can also wait like 3-4 days to buy new stock, but you have to wait at least 1 day.
One.
Like I would solve it naively using like a backtracking. Like what I mean is like I will suppose this is the thing. So like I can try with buying in day 1, okay, or not buying in day 1. And if I buy, then I have to sell the next so next time. So like then I have to sell or not sell, but I have to sell in some day, and then I can do it again and see the maximum profit that I can make. Like I just try all the possible combination. Like I can like buy in day 1, and then I pass this function again, like 2 3 0 2, but I have to sell it the first, like the next time. Or I choose not to buy in day 1, and I just do 2 3 0 2, and I have to buy the next time. So now for this case I have to sell, right? So I can like choose to sell in day 2. So if I sell it, then I will get 3 0 2, but because I sold it, I cannot use the 3 again. So I have to buy, and I have to buy the next time. And because I have bought I didn't buy the next in the day 1, I can buy the next day. Like I can buy I can buy 2, and I can get 3 0 2 as sell. And I can choose not to sell it in the second day, or I can choose to sell it. So if I sell it, then I will get 0 2 as buy, but because I cannot buy in the next day, I have to pass 2 to buy. Or I can choose like not to sell. In that case, I can do 0 2 and sell again. So this will be my backtracking, and I will consider all possible situation and get the maximum.
Okay.
But here you see there is one like we are solving the same sub problem again and again. Like 0 to b can be also present in other case, So we can think of DP.
Then, yes.
DP, like we can have a DP like array of like I to j, and we can have like we have to do it a buy or sell. Buy or sell, and we can store this and use it again and again. Does it make sense?
Yes. Like if we use two arrays, like one for selling and one for buying.
Yeah, that can also work. Yes, that can, I think that will be easier to implement. Yes, so let's go with that. Do you want to implement it? Yeah, you can try.
Okay, let's.
Yeah, so yeah, you can implement it using that. And let me stop the screen share, and you can start.
This is our array 1, 2, 3, 0, and 2. And for the I suppose I at the index of I. So we have to give one day of cooldown after the selling, right?
Yeah.
So will it be like? I cannot think of the relation actually.
Okay, I can help you with the relation. So let me write it in the Google Doc. So we have like DP. So we have two DP of cell. DP of cell and DP of buy. So DP of buy will be like I'm just thinking. So DP. So suppose we have array, right? So we can do like suppose we have the first day, we buy in the first day. So we cannot sell in the we can sell in the second day. We cannot buy it, right? So if we buy in day I, then our answer will be like DP of cell I plus 1 and if you buy in day 1, the answer will be DP of cell I plus 1 and if you sell in day I, then we have to do DP of buy I plus 2 because I have to give 1 day of this. So DP of sell and DP of buy will be the best like the best possible case we can get if we sell at day I and if we buy at day I. Like DP of buy is the best profit we can make if we buy at day I and DP of sell I it's the best profit that we can make if we sell at day I. Okay, so if we buy at day I, the answer will be dp of sell, like we can sell actually in any day, right? So we can say like it will be maximum of dp of sell I, like I plus 1, and dp of sell I plus 2, like continue, something like that.
Okay.
And if you sell at day 1, it will be also maximum of dp of I by I plus 2, dp of by I plus 3, and so on. Something like that. What do you think? This makes sense?
Yes.
So we have this, or there's like one more way that we can try to solve it using backtracking, and then we can use some kind of memorization, like we can store it in some cache after we solve it using backtracking. I think that will be easier to implement.
Yes.
Okay, so how would you implement using backtracking? Yeah, we can solve it using backtracking, then we'll understand, and then we can use the DP to solve it in a better way. So how to solve it using backtracking? Okay, let me write the functions. How to solve it using backtracking. Definition, backtrack.
So are you writing the solution?
Yeah, I'm just trying to like figure out. So how would I?
So should I stop my screen share?
It's okay. You don't. So if I have definition of backtracking, but so the backtracking, how to solve it using backtracking? So we can start from. So we have an array, and we have like, okay, let's pass index, and if index equal to length of prices, we like stop return. Okay, this is the base case. And let's try to find the other cases. So, and we also have to pass, like we need to buy or sell. So let's pass is,
2 boolean values.
yes, like is buy, something like that. So if you have is buy, if is buy, so we have to buy it. Sorry. So if is buy, we have to buy it. So if we have to buy it, so either I can buy now, or I can buy the next day. So if I have to buy now, then I will buy it. So I will buy it at So I will buy it today. So the price will be prices index. Okay. Or I can do a backtracking. I can do a backtracking of next day, which will be index plus 1, and is buy will be still be true. And if I buy today, then I have to sell the next day, sell the next time. So we have to pass we have to do backtracking, and index plus 1 is by will be like is by will be false. We have to sell it, right? And it will be is by will be true if we have to buy it. And we also have to keep track of the profit that we are making. So we have to also pass like profit, and when we this so we will have a self dot maximum profit, which will be 0, and when you reach the end we have to do like self max profit will be maximum of self max profit and profit. That makes sense?
Makes sense.
So, and now when we sell, then we have to get the price, like profit. So here we have to pass one more variable, like the last price, like if I have to sell, like I'm sell like else, so we have to sell, right? Which we can return. We don't have to go more. So because we should avoid the else conditions as much as possible. So here we have to sell. So now what will be the profit? Profit will be, so I can sell now or I can also sell the next day. Two options. Two options. Sell today or sell next day, or the like we can like sell next time. So for the sell next time, it's like backtracking index plus 1 and price false, and profit will be profit is not changing, so I'll just pass profit everywhere. Profit and profit. But if I sell today, I make some profit. So profit will be plus equal to the price of today, like sell price, like sell price will be prices and index, today's like price, because we are selling today. So the profit will be sell price minus, like we have to pass one more variable, like when I bought it, what price I bought it, by price. So I have a buy price, so sell price will be sell price minus buy price, and I have to backtrack, and because I have sold it today, I cannot sell it at plus 2, yes, and I have to pass it as true, because next time I have to buy it, and I have to pass profit and buy price. Buy price will be 0, like because I will buy the next time, right? So I don't have to consider buy price. So buy price will be 0. But if
but in the sell next time, shouldn't it be the buy price?
Which line?
In the line 35.
In line 35, the sell next time will be it will be sell buy price, right?
Buy price.
Yes, because we have not bought it yet, so I have to do it the next time. So we have the buy price and profit. So I also put buy price in here, and also buy price in here. Like, okay, if we buy now, then the buy price will be price, right? Because we're buying today, so we have bought it, so it will be price, and sell price will be this. And also you have to make one more case, if index is greater than length of prices.
Put it in this actually, like the equal. Oh no,
Yeah, like return,
Mm.
so that we don't have an array out of bound index. Because
Mm.
here we can, when we are doing +2, then we can reach the end.
Mm.
Like when you reach the end, when you sell it
Mm.
like the last day, we can again
Mm.
might try to buy like some array out of bound, so we can prevent it using index this. Okay, do you think this looks okay? Backtracking, index +1 false. So let's check the flags one more time, all the plugs. So we have this, and let's also write the driver function here. So backtrack, and index will be 0, and I have to buy first time, so it will be true.
Yes.
Buy price will be 0.
Price of 0.
Yeah, and profit will be also 0. And
so buy price will be price of 0.
1 second. Return self dot max profit, right? Yeah. Right. 1 second. Line number?
Line number 34. Like the third argument, shouldn't it be price of 0?
Yeah, buy price. No, actually, when we buy, then it doesn't matter, right? Like, because suppose we are buying here, is buy.
Oh yes.
Yeah, because it doesn't matter, because we are buying that time. So the previous price of buying doesn't matter. But when you sell, it matters.
Okay.
The buy price. So because we have to buy the first time, so we can just pass 0. Right? Okay, so let's try. So let's go through the code once again and try to see. So if index is greater than length prices, then return. We don't have to do anything. And if you reach the last one, so we just update. And actually, we can also do it like combine these two as like this, right? Okay, so
like, don't we have to check the is by variable? Like if we just bought one item and haven't sell it.
Yeah, right. In this case, the profit will be, but profit will be profit, right? So that doesn't matter. Like, I understand your point is like,
yes.
What if we sell or buy? Like,
what if we do not sell one item?
That's okay. Like, does is by flag matter here? That's your question, right? I think it doesn't matter, because suppose we have two cases, right? One is we have to buy it at the end or sell it, but whatever the thing is, the profit is already made, okay? And at the end we are not doing anything, so we don't need to consider this flag. That's what I think. Okay, so now if is buy, we have to buy it now, so we can do two things. We can buy today, or we can buy the next day, like the next time. So if we buy today, then the price will be the price of index, and we are buying, so we have to update the price by this price, and profit will be profit, and backtrack the next one, because next day we can sell, and we are making this flag as false because we can sell, and or we can do the next time, like we can buy the next time, so we just do index +1 and true, buy price and profit. That's it. Or we can sell it, or if this flag is false, then we need to sell it. So the sell price will be prices of index, so at this price we have to sell it.
Okay.
We have like two options, like sell today or sell next time. So next time is like very simple, so we just do index +1 and false, and buy price and profit. We don't do any update here. But if we sell today, the profit we make will be today's price minus buy price, at which price we bought that share, and we update this profit, and we reset the buy price to 0, and we backtrack. So that is my solution. Do you think it should work?
It should work.
Okay, let's run it the code. Okay, we got this 3. So I think this will work, but we might get timeout because it's not very optimized. But let's see. Okay, so we got something wrong here. So we have 1, 2, and 4. Output is 3. Okay, so we are getting output as 4, but we should get 3. What is going on here? So
we haven't set a buy price somewhere.
Yeah, so buy price is like not set maybe somewhere. So price is the prices dot index and backtrack index plus 1 by today or by the next time. Okay, let's print something here and see what happens. So we are selling here, right? So print.
So this will be else, right? If else.
Yeah, I think I'm doing return here. So print sell price index. So in case of, okay, let's do a dry run and see where the code might get wrong. So we have 1 to 4. Okay, can you do a dry run? 1 to 4. So what will happen?
So at first 0, true, 0, 0.
So yeah,
Okay, we will buy it.
so we have 0, true, 0, 0. So we have is buy is true. So we can buy today, and what will we send? Backtracking of 1 and
is false. Price will be 1
price will
and
be,
profit will be 0.
profit will be 0. Okay, and okay, so let's keep going. So now we we have this one. It will be backtracking of 1
1 true, 1 and 0.
Buy price.
Will
Yeah,
be
buy price will
1.
be, it will be 0, right? Buy price should be 0 and profit is 0 because you not updated.
Yes.
Okay, now we have this. So let's consider this case. We have 1 false, 1 and 0. So now we have, it goes here again, and we have index. No, we have sell, right? We have false, so we have sell here. So we can try to sell it today.
Okay.
So sell price will be so index
2.
is, okay, sorry, index equal to now 2, and we have this condition, backtrack 1 false, 1 0. So now index will be
1. Index will be 1.
Index will be 1. So now
Sell
we have
price
to
is
sell.
2.
Sell price will be
2.
And profit will be sell price 2 minus
2 minus 1.
1.
So 1. Profit
1.
will be 1.
Will be 1. So now we backtrack 2 true, and true, and profit 0. Profit is 1.
Index is 1, right?
Then we do index plus 2, right?
Index,
So
1 index plus 2, so it will be 3.
3, yeah. 3, true, 0, 1.
Hmm.
So when we have 3, then it will stop, right?
Yes.
And we update the max profit to
2,
max profit will be 2.
1.
Yeah, sorry, max profit will be 1, right? Because we
1.
have 1, yes. Now we have the case of buy. So we have bought it at. So yeah, so now we again have this case that we don't sell today, we sell the next day.
Next day.
So it will be backtracking of we have 2, right? Index will be 2, and
this will be false.
Buy price will be 1.
Price will be 1. Yes.
Profit will be 0.
0.
So now we come here again, and now we try to solve it for 2. Like we are selling at day 2. So sell price will be prices of index, which will be 4.
4, yes.
Right? And profit will be
4
sell
minus 1,
price
3.
3.
Hmm.
And backtrack will be 5, true, 0, and 3. So why are we getting 4? The question is why we are getting 4. Okay, we can do one thing. We can print index. We can just print the 4 variable where we are setting it. Why profit is becoming, sorry, let's do 1 to 4. So in this case, profit is becoming 4. 3 false, 1 4. And 3 true. Why profit is becoming 4? 4 is the profit. Okay, can you think of when it is getting 4 in this code?
In the
Profit is always sell price minus buy price. Oh, we are doing plus 1. So one time we have maybe we are getting 1 somewhere, and 1 plus 4, 3. So we have 3 true, 0 and 1.
0, 1.
So 3 is the index, and 0 is the buy price.
Is buy.
And 1 is the profit. Yes, so
Equals buy price.
yeah, that is the first case.
Okay. Oh, yes.
And now we have 4 is the index, 0 is the buy price, profit is 4. So how we are getting profit as 4? Answer. So let's just print profit and index. Oh, I think we are setting the profit here, right? Yes, so that's why I'm making mistake. I got it. So here we're setting this profit here.
Yes,
so,
yes.
Yeah. So like let's make it original profit. Okay, let's make a new profit. New profit will be profit plus this, right?
That line should be
Silly mistake. And we pass the new profit here, and we pass the profit here.
okay.
Yeah, cool. One silly mistake. Okay, let's do this 1 to 4. Yes. So yeah, so our solution is correct. We just need to optimize it. Okay, we got time limit exceeded. So now we need to optimize it. Our backtracking is working fine. So let's just look out the code. Okay, so do you think we can do a caching here, memoization here? Is possible? I think we can do it. We can just like cache the answer. So backtracking, because this one we are doing it repeatedly. So this profit we can save it in some. We can have a dictionary of this element, and like if I have to do it like self.cache will be this, and when we get the return, then we can self cache. So for this index is by price and profit, we can put in cache, right? We can cache the result. How would we cache it? So because we are doing a backtracking, so I don't think we can do caching because we're doing backtracking. So because we don't have any track, we are not getting the value from like there. But maybe what we can, and we have this profit which will keep changing. So I think caching is not a good solution. Is there any way, any like sub problem that we are solving repeatedly? I think we are solving this one repeatedly, right? This backtracking index true false
+1.
yes. And this, so I think what we can do is, if we pass the profit as a result, then we can solve it. I'm not sure, like like we are doing it from recursively. Can we make it iteratively and then solve it? How to cache it? Like what we can do is maybe not pass the price, but when we buy it, pass the index, when we bought it. Like, and then that can help us to solve this thing. Can we make a DP from here? Okay, so the answer is like we have to do something. So we have to change it little bit, and instead of this buy price and profit, we have to pass the sell index, or like buy index and sell index.
Buy index and sell index.
Okay, then
Yes.
we can solve it. So how can we do buy index and sell index and solve it? So what we can do is so we'll discuss one method that we have seen in the, which is similar to our solution. We'll discuss it. And Java. Yes, so let's try to understand it first. Return get maximum price. Okay, I have to also build it. Okay, so we got a working solution, Java, that is almost same as what we solved, but they used the almost the same way, but they have managed to make the cache like a memo to solve this problem. So let's go through the solution, and because this is similar to what we make, so forget this dputil. I think we don't have this one. Yes, we only need this. So as you can see, this code is running, and this, if you submit it, it will, yeah, it's success. So let's just discuss the solution here. So we have, so instead of keeping track of the profit, we keep track of two indexes, like buy index and sell index. And we have the prices, which is the array that we passed, and we keep track of the profit between this buy index and sell index in a memo 2D array. So let's see what they have done it. So now we have the base case that if buy index is greater than prices dot length, or sell index is greater than prices dot length, then we cannot do it anymore. We reach the end, so we return 0.
Okay.
And if we already have the solution of buy and sell index, then we return the buy and sell index.
Memorization.
Yeah. Or we compute the memo. So if the price of sell index is less than the price at buy index, then we cannot do anything. We just return we
just go to the next index,
because
buying is not possible.
So we just try to buy from the next index and sell from the next to next index. This is the or we can buy it. We can sell it. So if we can sell it, we have two options: either sell now or sell the next time, that we did before. So let's make this and this so that we can understand. So we have two options that we can int price, like profit.
Profit.
Yeah, profit. now profit now will be the price of, so we just sell it right today, and we also now and from, because we sold at sold index, so we can again start. We have to give 1 day of cooldown, so we can do it from +2, like
Yes.
after 1 day, and the sell index will be +3 because we have to buy after this index.
Yeah.
So profit by selling now, and it will be maximum of math this, or we can sell it the next day,
Next day. Yes.
which will be +1. So this is the way to solve it. It is the same of what we did, but little bit better because of keeping track of the profit, we just keep track of buy and sell index, so that we can build this matrix in a right way. But in the interview, even if you can solve using this backtracking, you will get some points, and maybe you will get the offer, because no one expect you to come up with this solution by yourself, and the interviewer will guide you to how to reach this solution. But it's great that we had a good thinking process, and you can solve it in this way.